Hi, this is Jose Luis and welcome to another video in the series Fun with WebSockets. In this video, I would like to teach you how to write a WebSocket server in Python. And the way we're going to do this in this video is we're going to write a simple echo server, which is going to send messages back to whoever connects to the server. But we're also going to write a broadcast echo server, which means a server that is going to send an incoming message to all the other clients except for the sender. So in a broadcasting way, which is going to look something like this. So if you see the terminal that I have here, I'm going to start running the server, which I just started. And then I'm going to run the first client, which is going to connect to the server, but it didn't get any, and it sent a message. And now the second one is going to connect, and the message that is coming in sending this one is received by the server and is broadcasted to the other client. And the third server client that I'm going to connect is going to send a message to the server, and that message is going to be broadcasted to the first one and to the second one. All right. So I'm going to explain, we're going to be using the code that we have used in the previous videos for the client, but we're going to be writing the server from scratch. Okay. And I would also like to thank Salvador from the Parametric Camp community who helped me put together this example, and hence here we are today. Okay, so thank you very much for that, Salvador. And before we start, no, we can actually start, I think. Let's get hands-on and let's see how to write a WebSocket server in Python. So let's start by refreshing what we did in the previous video when we wrote a Python client, a Python WebSocket client. If you remember, I had on my desktop in a folder called Python WebSockets, I had a client.py file which had this code. And this code was the code that we were using as a WebSocket client to connect to all this like ball chasing synchronization stuff that had been developed previously in the playlist. So what we have here is that now I can run either from the terminal, I can open a terminal here, or what we're going to do is we're actually going to start using Visual Studio Code terminal. So what I'm going to do is I'm going to go to the client, to Visual Studio, and I'm going to click on terminal, start new terminal. And then you're going to see that all the way down there, I have in my case, I have a PowerShell bash that I can use to run commands here. So what I can do is I can go to the folder where my client script is, and I can type here cd, and then I can paste that folder there, and I can type dir, and you can see that I can see client.py, right? And then if I now type Python and then client.py, then you can see that I have, you can't really see because there's no, but I have connected to the glitch server. And now if I click on, maybe I have to refresh this. So now if I click on the ball chasing, you can see that it synchronizes and that it sends messages to the WebSocket client that I have connected here. Okay, so all right, so this is good. And then what we're going to do now is that instead of using the client to connect to the glitch server that we have developed in the previous videos, we're going to do everything locally. So I'm going to just close this. And what I'm going to do is I'm going to create a WebSocket server that is going to be written in Python that is going to live on my local machine. The way I'm going to do that is by opening, I'm going to close this here, all right? And I'm going to type CLS to clear the screen. And then what I'm going to do is I'm going to create a new file, for example. So I'm going to create new file, and then I'm going to save this file with Control S. I'm going to save it as, for example, server echo.py. And as I do that, I'm going to dock this side by side. So I'm going to put this on the side here. And then I now have the two scripts side by side, the client and the server. All right. So I think at this point, we are ready to start working on the server. And then something that I'm also going to do for the sake of development, which is very nice on Visual Studio Code, for example, is that I'm going to create two terminals. So here I'm going to go to the terminal that I have, and I'm going to split it. And therefore, now I have two terminals, one on the right and one on the left. This one, I'm also going to cd into the folder that has my scripts. So now you can type dir, or ls, and you can see like all the files that you have on your system. And then, because I will use this to run the server on the right hand side, and I will use this terminal to run the client on the left hand side. Okay, so I think at this point we're ready to start writing our server implementation. The way we're going to do that is going to be simple. We're going to start by importing the relevant libraries. So we're going to just import the same libraries as we did for the client, which is going to be the WebSockets library. And we're also going to import Async.io, which is the library that allows us to do asynchronous non-imperative programming inside of Python. So basically the idea of like having a function that is waiting and that responds when we get particular events are recent, right? Recent? I don't know how to say that. Anyway, I'm also going to define a new variable that is going to be the port, which is something that I didn't do before, which is going to be, for example, 7890. This is going to be the port that local connections need to connect inside of my computer. So that's a new variable that I'm creating. And then just for the sake of login, I'm just going to say started the server and it's listening on port, for example, and then here I'm going to type, oops, I'm going to do this, yes. So, and then I'm going to use the string function to convert this number into a string that can be connected to this string here, all right? So, so if I now, just for the sake of trying, if I now go here and I type Python server and I start my server, you can see that I get this message, but nothing happens because it just executes and it finishes, right? And I have I'm just going to change this server listening on port, blah, blah, blah. All right, okay. The next thing that I need to do is I need to define a function that is going to be the function that is going to be running on the WebSocket server, so that whenever a socket connects, a WebSocket connects, a client connects, then that function is going to handle the behavior of the server for that client. And in this particular example that I'm going to write right now, we're going to write a simple echo server, which means that whatever message comes from a client, that message is going to be bounced back to that client. So whatever the client sends to the server is going to send that back to the client as well. So how can we do that? Well, we're going to define an asynchronous function, a function that is going to be living and listening. And then we're going to define it and we're going to call it, for example, echo. And this function is going to take two arguments, which are going to be the WebSocket and the path. The WebSocket is going to be an instance of the WebSocket client. So whenever we need to refer to the client, we can use this argument here. And path, we're actually not going to be using it. So if you don't want to use it, it's also fine. And then we're just going to print some acknowledgement message. So for example, because this function is going to execute whenever there is a new connection. So we can just write here a client just connected. All right, just to make sure that we have some logs here on the screen. And then here, what we need to do is now we need to implement the logic of whenever a message comes from the client, then send that message back to the client. So what we can do is we can write what's called an asynchronous for loop, which is whenever we get, it looks something like this. So whenever we find a message that is coming from the WebSocket, what we need to do is whatever we specify in this function. So what we're going to do is, for example, I'm going to write a message. So I received a message from the client, and the message is going to be whatever message, all right? And then I'm going to send that same message back to the client. So, and I'm going to do that with an await keyword, which is going to be WebSocket.send and then the message back. And we could actually add something here like back, or for example, response, or pong, like when it's as in ping pong, for example, whatever. Uh, what is going on? Exactly. All right. Now, let me break this down a little bit for you. So what is happening here is that while we need the asynchronous and the await, because the WebSocket client may actually be sending several messages very fast to the server. And then what we need to do here is we need to write some code that makes sure that it takes one message at a time, it deals with that message, and then it doesn't start over again until that message has been handled, has been dealt with. This is why we have here a for each, so that we iterate over all the messages that might be coming very fast to the server, but we do it in an asynchronous way, so that the next loop of this message doesn't happen until we know that we have sent back the message to the client. I'm not sure if I did a good job at explaining this, but basically imagine the situation that the server receives 1,000 messages very fast. What this code does is it goes over each one of them one at a time, and it reads that message, it sends back that message to the client, and it makes sure that it doesn't go and send the next one, it doesn't deal with the next one until this sending back to the client has been complete. Okay? I don't know if I did a good job again at explaining this, but I hope you trust me on that one. Okay? All right. Now, and remember that whenever we have an await, we need to wrap it with an async, and that's why we have these two clauses together here. Alrighty. So at this point, the behavior of the server is ready, but we have not really implemented anything that uses that behavior as part of a WebSocket server. So that part we can do by using, for example, by using from the WebSocket server, we can use the serve function, all right? And then we can pass in the echo function that we have designed. And then the second argument is going to be where this server is going to be living. So that's going to be localhost, which is a term that refers to this machine. I think we saw that on previous videos, all right? And then the port that we're going to be running this server on. That is going to be whichever number we have defined here for this variable, okay? And what this function does is that it returns an instance of that server. So that we can keep it inside of a variable. So for example, I'm going to call this start server, and then I'm going to keep the whatever I'm getting back, the instance of the new server, I'm going to keep it inside of this variable. Last but not least, we need to actually start the server in an asynchronous way. So the way we're going to do that is from the async.io library, we're going to get the event loop. And then once we get the event loop, we're going to run until it's complete. We're going to run that instance of the start server that we have defined. So we're going to run that once, and then we're going to make sure that the event loop after that is running forever, so that the server stays alive, so that the server doesn't stop working. Okay, so I think we are ready to give this a try. The way we're going to do that is in the terminal that I have on the right hand side. I'm going to start my server. So I'm going to say Python and then server echo. It's very difficult to read. I don't know how to make this terminal larger. So, but you can see that I get an acknowledgement saying that the server is listening on port 7890. which means that the server should be fine at this point. Now, let's try connecting from the client to the server. In order to do that, the first thing that I need to do is I need to change the URL, because the URL right now is pointing to the server that I put on Glitch, whereas this server is living on my machine. The address of my machine is, as we discussed in previous videos, is this special IP that is called 127.0.0.1. And then, with a colon, I need to specify the port, which is 7890. All right, I'm going to save this, and then in my other terminal, so that I have the two terminals side by side, I'm going to type Python and then client. And what that's going to do is that it's going to start the client and it's going to immediately connect to this server that I have running here in the other terminal. Let's give that a try. So as I do that, you can see that I get a message here that says that the client just connected, which sounds like it's working well, but nothing happened. There was like no messaging, no echo going back and forth, which is kind of weird. So I'm going to stop the client by going to the other terminal and hitting Control C to stop the process. And then you can see that I get a lot of errors, and I also get quite some errors here on the server, but the server has not actually stopped. It has just dumped like a bunch of errors. So we will deal with that later. Okay. So I'm going to clear all those errors by typing CLS, and then what I'm going to do is that I'm going to change my client so that as soon as I connect to the server, I send a greet message like, "Hello server, how are we doing?" The only thing that I need to do is here inside of the async connection to the WebSocket server, what I need to do is I need to send a message, but I need to send it with a wait so that I don't start dealing with the following code until this has resolved positively. So the way I'm going to do that is I'm going to take the WebSocket instance and I'm going to send a message that is going to be, for example, "Hello server," something like that. Okay, I'm going to save that, and then I am going to hit the arrow key up until I find again Python client, and then I'm going to run this again. And can you see what just happened? So the client connected to the server. Then I got a message here saying that the client just connected. And then I got another message saying that I received a message from the client, "Hello server." And because I sent the message back with this, you can see that in the client now, I am receiving the message that is called Pong, and is "Hello server." Hooray! So it looks like this is working. The client connected to the server, it sent a message, the server received the message, and it ponged it back to the client. Yoo-hoo! So we have the basics working here. How can we make this a little cooler, better, and like avoid all this like clutter of error messages? How can we do that? The first thing we're going to do is we're going to improve the server a little bit so that it doesn't dump all these messages when a client disconnects. All right, so what I'm going to do is I'm going to stop the client with Control C. I'm also going to stop the server with Control C, and I'm going to clear all the clutter, CLS and CLS. All right, and then the the idea is that the error messages from the server are caused because when the client disconnects, there is no WebSocket that we can cycle through and that we can send messages back to. So basically, this code here fails because the WebSocket is not present anymore. So when we want to deal with errors or with exceptions in computer code, we typically use try-catch structures, which are also present in Python. So the way we're going to do that is that we're going to use try, and then we're going to wrap all this code, the code that we think can be faulty, into a try clause. And then what we need to do is we need to handle the exceptions that might arise from this code here. So we could just say like we could just say, if there is an exception, then just print the message like something went wrong, something like that, for example. And let's give that a try. So I'm going to run the server, I'm going to run the client, everything goes well, but then when I stop the client, you see that now instead of the whole dump, what I get is a simple like something went wrong, okay? But that is because the only thing that we have done is we have added a general handler for any exception that might happen. In this case, because we know that we want to be able to handle precisely the case of a client disconnecting, then there is particular exceptions that we can target, because when an exception is raised, it's typically raised with a particular signature. What that means is that, for example, in the case of the WebSocket library, we can go to whenever in the WebSocket exceptions we find an exception that is connection closed. All right. So if that is the exception that we have found, just give it a name. For example, it's going to be E. And then here the message is going to be different. It's going to be a client just, oops, sorry for that. A client just disconnected. And then we're going to print the error message just to make sure that we see it. So I'm going to close this, and then I'm going to CLS, and I'm going to start the server again. I'm going to start the client again. I'm going to disconnect the client, and you can see now that the message is a client just disconnected, and the code is the connection was abnormally closed for no reason, whatever that means, okay? All right, so that looks much better because now I can connect and disconnect, connect and disconnect, and things are much better handled now. And so I'm just going to remove printing the error message, and I think this is going to be good for handling the error of the disconnection. So I'm going to close my server, I'm going to close my client, and everything there is disconnected. All right, and I think we are ready now for a bit more of enhanced server behavior. What are we going to do next? I think what I would like to do now is to implement a broadcasting echo server. What that means is that it's still going to be an echo server. It's still going to bounce messages from the clients back to the clients. But the only thing that we're going to change is that if we have multiple clients connected, then whatever message is received by one client is going to be sent to the rest of the clients, but except for the one that sent the message, so that whoever sends the message is not receiving the same message back. So how are we going to do that? Well, first of all, I'm going to save a new file. So I'm going to go to File, Save As, and I'm going to write here server echo broadcast. All right. And then the next thing that I'm going to do is, what I need to do is the first thing that I need to do is I need to keep track of how many clients are connected to my server. So what I can do for that is I can create an array, or I can create a list, or whatever. But in this case, we're going to use a set as a data structure so that we can be sure that there's going to be no duplicates in that list. So what I'm going to do is I'm going to create a new variable that is going to be connected, for example, and then here I'm going to create a new set. All right. And then what we're going to do is whenever a client connects, we're going to add that client to the set. So we're going to say connected.add, and we're going to add an instance of the WebSocket that just connected. So this set is going to keep a copy of all the WebSockets that are currently connected to my server. And then what we're going to do is whenever we receive a message from the WebSocket, what we're going to do is we're going to keep printing this message to the console, but instead of sending the response to that same WebSocket, what we're going to do is we're going to iterate over all the sockets that are in the connected list. So, for example, we're going to say for connected in connected. Oh. So for each one of the sockets that is in the list of connected sockets, what we're going to do is if that one, the one that we just chose, is different than the one that sent the message, which is WebSocket, because we are in this function, then if it is different, then await, connect, let's send a message. For example, someone said, and then the message. Okay? And the rest is going to stay the same, correct? Yes. So let's give this a try. So I'm going to write Python and then server echo broadcast. So now I'm going to start the server. And then here, I'm going to create a new client. So you can see that this looks like it's starting to work because the client did send a message, hello server. And we know that because the server actually logged that. The problem is that no one else received that message because there's no more clients here. So what we're going to do is we're going to go here to this terminal, and I'm going to click here on the tiny icon that is a split screen, and I'm going to create a new terminal, and I'm going to create another terminal and another terminal. So I'm going to create 5 terminals, and I don't know if you can look at, maybe I don't need 5, maybe 3 is enough. But maybe you can see here, I still have the server on this one. All right, but I have two other terminals. So I'm going to copy the route of where everything is, cd, and I'm going to paste the route, and cls, and then cd, I'm going to paste the route, and cls to clear the screen. All right, so now I have these 2 other terminals that are on the same folder. So now what I can do here is Python, and I can start the client. And then as I do that, what should happen is we should see here messages for the connection. And then this terminal here should receive the message that this client is sending to the server. So let's see that. So I'm going to click that. You saw here a client just connected. I received the message, hello server. And then this client, the one that was previously connected, received someone said hello server. So the message that this client sent to this server was bounced to this other client. And then we're going to try with the third client as well. So I'm going to type Python, and I'm going to say client, and then what we should expect is it's the same message here, but these 2 other clients receiving this message. So let's try that. So I did that, we got the acknowledgement, and then we got the message for this client, and we got the message for this client as well. So, yoo-hoo! So this is working. It looks like we have, it looks like this is working. But I think if I close this up and I now connect another server again, we are going to get errors. Anyway, something that I would like to do is I would like to make sure that if we have an error because the connection is closed, I would like to make sure that from the connected list, I would like to remove whichever WebSocket whichever WebSocket has left the party. All right. So that's why I'm going to add here to the try. I'm going to add a finally, which is going to be the part of the try catch clause that is always going to execute no matter the exception. And we're going to make sure that we remove that WebSocket from the list of connected sockets. Okay. This is just for making sure that things are clean and well written. All right. Okay, so I think you can't really see this. So I think this is what I wanted to cover in this video. This is a way of making a simple WebSocket server using Python. We have written a simple echo server, a more complex echo broadcast, but now you can see how you can just add more behaviors. You can take the message that is coming in and you can use that message to change the behavior of the server, to send other data to the clients, to connect it to operations, whatever. The sky is your limit now with this, okay? All right, wonderful. So thank you very much for watching this video. If you like the content, maybe consider liking this video or even subscribing to the channel, hitting notifications on, and all those things that help us send the message across. And in the meantime, maybe you want to consider continue with this playlist and see what other things we have that we can have fun with using WebSockets. See you on the next video. Bye.